Hey kids, welcome to Fun Learning. Today, we will learn about the Newton laws of motion. Who was Newton? What is his full name? Here is Isaac Newton. Sir Isaac Newton was born in 1643 and became famous for his work on gravity and his three laws of motion. He was also well known for his work on light and color, and what is now called calculus, a branch of mathematics. Let's start with the law proposed by Isaac Newton. A scientist, Isaac Newton came up with three laws of motion to describe how things move scientifically. He also described how gravity works, which is an important force that affects everything. Newton's first law of motion. First law of motion is also known as law of inertia. If Newton's first law of motion is called the law of inertia, we must first define inertia. Inertia is the tendency of object to keep doing what they are doing. If an object is resting, it will tend to keep resting. If an object is moving, it will tend to keep moving. This property is called inertia. An object in motion tends to stay in motion and an object at rest tends to stay at rest, unless the object is acted upon by an outside force. The law also says that when an object is moving, it tends to remain moving along a straight line path unless acted on by an outside force. An object at rest will remain at rest, unless acted on by an unbalanced force. An object in motion will continue with constant speed and direction, unless acted on by an outside force. We feel the effects of Newton's first law every day, but usually don't notice them because other forces interfere. In space, the first law is much more obvious. Objects will follow their path until they are acted on by an outside force. On Earth, the atmosphere, air friction, will eventually slow down all moving objects. But in a vacuum-like space, there is no air friction to slow down objects, and the first law is easy to see. Some everyday examples of law of inertia. One of the most common places people feel the first law is in a fast-moving vehicle, such as a car or a bus, that comes to a stop. An outside force stops the vehicle, but the passengers, who have been moving at a high speed, are not stopped and continue to move at the same speed. Seat belts and headrests, you need them because of inertia. If there is no seat belt, you will continue moving forward. An astronaut in space throws a rock. What will the rock do? It will continue to move in a straight line at a constant speed until an outside force acts on it. Think of a ball in a cart. When you jerk the cart forward, what does the ball do? The ball will hit the back of the cart. Why? The ball's inertia will keep it at rest while the cart moves under it. Is a force required? If you were in a weightless environment in space, would it require a force to set an object in motion? Yes. Because even in outer space, an object has mass and therefore it has inertia. If an object has inertia, then the object is going to resist changes in its motion. A force must be applied to set the object in motion, even in space. So Newton's first law of motion states that things will continue to do what they are doing unless an outside force acts on them. Applications of the first law of motion. A book lying on the table. A book lying on the table remains at rest as long as no net force acts on it. A stone in the ground is in a state of rest and will remain on rest until an external force applied on it or move it. Newton's second law of motion. When a force acts, pushes or pulls, on an object, it changes the object's speed or direction. In other words, it makes the object accelerate. The bigger the force, the more the object accelerates. The mass of an object affects its inertia. Objects with more mass have more inertia than an object with a smaller mass. It's harder to make a large object move or change the speed and direction of it when it's moving. The application of the second law of motion can be seen in identifying the amount of force needed to make an object move or to make it stop. Following are a few examples that we have listed to help you understand this point. Kicking a ball. When we kick a ball, we exert force in a specific direction, which is the direction in which it will travel. In addition, the stronger the ball is kicked, the stronger the force we put on it and the further away it will travel. Suppose two people are walking, and among the two people, if one is heavier than the other, then the one weighing heavier will walk slower because the acceleration of the person weighing lighter is greater. Pushing a shopping cart. It is easier to push an empty shopping cart than a full one, because the full shopping cart has more mass than the empty one. This means that more force is required to push the shopping cart. Riding a bicycle. When riding a bicycle, the bicycle acts as mass and our leg muscles pushing on the pedals of the bicycle is the force. The third law of motion states that for every action, there is an equal and opposite reaction. Force always exists in pairs. Though action-reaction are equal and opposite, they never cancel each other. A single and isolated force cannot exist. Physrt law of motion. Things that are still stay still, and things that are moving keep moving with a steady speed unless a force of some kind pushes or pulls on them. Second law of motion. When a force acts, pushes or pulls, on an object, it changes the object's speed or direction. In other words, it makes the object accelerate. The bigger the force, the more the object accelerates. Third law of motion. When a force acts on an object, there's equal force, called a reaction, acting in the opposite direction. This law is sometimes written that actions are equal and opposite. The application of the third law of motion can be seen through the following examples that we have listed to help you understand this point. When a man jumps down on the shore from a boat, the boat moves backwards. The boy feet exert force on boat, it's an action. However, the boat exerts force on feet, that's a reaction. When a man jumps down on the shore from a boat, the boat moves backwards. A fireman has to hold the pipe strongly in order to prevent it from going backwards, as the water flowing out of the pipe pushes it backwards. This is all for today. Thanks for watching. Happy learning with Fun Learning, where we prepare you for life.